Let's say you have a limit order on the exchange and you want to know the status of that order. Now, one way to do it is to periodically make an API call to query that order and know the status of that order. This technique is called polling and it's not really efficient because that order can be filled in the next few seconds or few minutes, or it could even take up to a few days. So you don't know when that event occurs. So you would end up making a lot of unnecessary API calls, which is really not that efficient. One way to fix this is by using a WebSocket that allows the server to communicate back to you when that order is filled. That way you would avoid making a bunch of unnecessary API calls, making your system more efficient. In today's video, we're going to talk about WebSockets. We'll start with the very basics. We'll understand the key concepts involved in properly handling the WebSocket and the technical jargon related to the WebSockets. Then we'll look at how to create and maintain a public WebSocket and how to restore the connection when there's a network issue. And after that, we'll look at authentication and how to connect to a private WebSocket. And towards the end, we'll look at how to use the same server that we built to relay the information back to the browser. And for all this, we're going to use Bybit Spot Exchange WebSocket, to demonstrate these key concepts. So although we are using the Bybit Spot Exchange WebSocket, the focus of this video is going to be on the concepts of WebSockets and not necessarily about Bybit WebSocket or Bybit Exchange. All right, let's get started. Now let's look at some key concepts or technical jargon, if you will. Understanding these concepts is crucial for us to be able to write the code properly. First one is the URL. URL is nothing but the link that you establish the connection to. In this case, I'm going to use Bybit Spot Exchange to demonstrate the WebSocket functionality. So we're going to connect to a URL to establish the connection. Once we establish the connection, it creates a long-lasting link between your code and the Bybit Spot Exchange that allows both the parties to communicate with each other. Next concept to understand is control frames. Control frames are different events triggered from the server to the client. So whenever you establish a WebSocket connection, the WebSocket state changes to open. So that's when you receive an open frame. Similarly, if there's an error, you would receive an error frame. So you need to handle these events in your code base for to ensure the WebSocket works properly. Similarly, message frame is used to accept any payload that is received from the server, and ping pong frame is used to restore the connection if the connection is lost and also to verify if the connection is active or not. We look at these frames in detail when we write the code. Next is actions. Actions are different events that we send from the client to the server. So you can send a ping frame. Ping is nothing but just pinging the server just to see if the connection is active or not. Emit is when you want to send a message from the client to the server, like if you want to subscribe to a particular topic or unsubscribe, you emit a message. And terminate, as the name suggests, if you want to terminate the connection, you can trigger a terminate action. Lastly, you have topics. Topics is nothing but a logical grouping for a particular type of data. For example, if you want order book data, then you subscribe to a particular topic. Or if you want candlestick data, then you subscribe to another topic. So yeah, there are different topics for different kinds of information. We'll look at the available topics later in this video once we write the code. But yeah, these are the different concepts that you have to understand. Just to summarize, URL is the link that you connect to. Control frames are different events triggered from the server to the client. Actions are the different events that we send from the client to the server. And topics are, different logical groupings that you subscribe to receive a particular kind of information. All right, enough with the theory. Let's start writing the code. Now let's start writing the code. As always, you would need NodeJS installed on your machine. You cannot directly connect to the WebSocket from the browser. That you would run into CRS issue. But towards the end of the video, I will show you a workaround for that. But yeah, for now, you need to do it in the Node.js. I also need these two packages to properly implement the code. First one is a WebSocket. This is just a module that allows us to connect to the Bybit WebSocket, and also .env to load environment variables. That's it. First, I'm going to initialize a Node.js project. Then I'm going to install these two packages. That's it. One last thing that I do is change the module type to module instead of CommonJS, because CommonJS is getting obsolete. Using modules, ES6 modules is the way forward. That's it. Now, here is the official documentation for the Bybit Spot WebSockets. I'll share the link in the description box. You can get it from there. And if we go to the connect section, this is the URL for the public WebSockets, and this is for the private. So we'll start with the public WebSockets. We'll understand, how to implement, how to reconnect when there's an issue. So we'll implement all the features, and then later we'll look at how to authenticate and connect to the private WebSockets. All right, I'll just copy this URL. We'll start with a very basic version of the code first. Like I said earlier, we'll just connect to the WebSocket and add a callback function to the open control frame, and we'll just see the WebSocket getting connected. So let's do that. The code is pretty straightforward, right? We're just connecting to the URL, and then we're just adding a callback function to this control frame. This is like an event listener, right? You have these different events that the server can trigger, like open, message, ping, pong. We'll look at the other events later, but yeah, here we're just adding a callback function to the open, which gets triggered as soon as the WebSocket is open. So let's run it. Awesome. So you can see the WebSocket is opened. That means the connection is established, but we're not doing anything. We're not subscribed to any topic, right? That's why you're not seeing anything happening as of yet. So let's connect to a topic and see the data come in. I'm going to create a new file as we keep increasing the complexity. That way, you would have reference of the old file, and it's easy for you to follow along. So let's look at the documentation. So if you go to the public channel, we have these different topics, right? Order book, K-line. K-line stands for candlestick data, ticker data, and all that. So let's connect to the candlestick data. And here is how we would subscribe to the topic. We would say K-line and interval. And if you click here, you will get the list of available intervals. Yeah. So let's subscribe to this, right? Candlestick 30 minutes and BTC USDT. So if we connect to this topic, that should give the data, the candlestick data 30-minute time frame on the 30 minutes time frame for this symbol. So let's do that. So we can subscribe to a topic by sending a message. So by using the command ws.send, and this is how we do it. json.stringify, and we have two parameters here. Operation is subscribe. OP stands for operation, and then we pass arguments. Arguments in the form of an array, and we just paste it here. That's it. How do I know this? If you read the documentation, you will understand this is the way to do it. But yeah, in the interest of time, I'm just going to show you that this is how you would subscribe to a particular topic. Let's Even if we run this, because we didn't add an event listener to the message control frame, you wouldn't see anything. So let's add that. On message. For now, I'll just console log the data. Let's run it again. It is connected. The data is coming in, but is in the form of a buffer. So let's stringify the data. Let's run it again. Awesome. So the subscription is successful, and you can see the data come in, right? So that's it. This is how you subscribe to a topic, and this is how you would get the data. Now you can do anything with the data in this callback function. It's quite easy, right? It's just like 10 or 15 lines of code, and that's pretty easy. But we'll increase the complexity a bit. Now what I want to do is when I start, I want to refactor this code. Although this looks simple and easy to write, I don't really, like the way it is structured. I want to make it easy to read and a bit more structured. And what I want to do is when we start the bot, I want to connect to two topics, and after a few seconds, I want to unsubscribe to a topic. So let's do that. Create a copy of it, demo3.js. First, let's refactor the code. The first thing that I would do is create a, I'm going to create main functions. You'll understand why I'm doing this in a bit. I'm going to call it restart, and everything related to starting the WebSocket would go into here. So I'll just take this one goes here, and these two would also go into this function. That's it. And then these callback functions, I want to write them separately. So I'll just say control frames. Sorry. This is what we're doing, right? I'll just copy paste here. And on message, that's it. So this looks a lot cleaner, right? We have all the functions, all the logic isolated into their own functions. I want to create another one called core logic. This is where we would execute the logic that we want. If you don't understand this, this is just an immediately invoked function expression, and I'm just calling this restart function over here. So what this means is as soon as you run demo 3, this function is going to execute immediately. The reason I'm writing this way is, once we are done with this entire code, you can just export the main functions outside this module and you can call them anywhere in your program. So I'm just building a module, so to speak, that you can just copy and use it in your code. That's it. So let's run this. I just want to see it works fine even after refactoring. Awesome. So it is working fine. I'll just stop it. Now what I want to do is when I start the bot, I want to subscribe to, you know, two topics, and like I said, wait for a few seconds and then unsubscribe. So for that, I need to create functions for subscribe and unsubscribe. So subscribe, and here we send the topics. Topics would be in the form of an array, and before we subscribe, just make sure that the WebSocket is open, otherwise it would throw an error. So let's do that. WebSocket.ready state equal to open. Yeah. So what this means is if the WebSocket is not open, we just return. We don't send anything. Let's.send, and it's going to be same as here, right? Just copy this, and instead of this one, you would set topics. That's it. Similarly, I need an unsubscribe function. You know what? I'll just duplicate this file and just call it unsubscribe. And instead of subscribe, I'll just say unsubscribe. That's it. Now, after the restart function, I need to call the subscribe. I want to subscribe to a few topics, but I cannot immediately call the subscribe function, right? Because the WebSocket status would still not be open. Ideally, what I would do is I would add an event listener and wait for the WebSocket to be open and then call this, but that would, make it so convoluted for you. So I'll just keep it simple just for this video. I'm going to wait for a second or so and then call the subscribe function. So let's do that. So now that I have this a promisified version of set timeout, I can just say await delay of 1 second. So what this does is it just waits for 1 second before executing the next line of code. So now I'll just say subscribe, and maybe we'll try something different. Instead of 30 minutes, let's look at the available intervals. So maybe we'll just say 12 hours. Yeah, 12 hours, and maybe XRP. Yeah, that's it. And after that, I want to wait for another 5 seconds, say, and then I want to unsubscribe to BTC. So So what should happen is, the bot should start. After 1 second, we should connect to these two topics, and after 5 seconds, we unsubscribe to XRP. Then we should only see the data for BTC. Okay, let's do that. Let's run the bot. Okay, WebSocket is success open. Subscription is successful. You see the data come in for both BTC and XRP. Then the unsubscribe is also successful, right? So that means XRP data would no longer be available, and you'll see just BTC data coming in. That's it. So it works as expected, right? The beauty of refactoring the code this way, now you understand the benefits of refactoring the code this way, right? Now you have these small functions that you can reuse, and it's cleaner and it's more readable, and you can also export these functions outside this module, and you can use them in the code anywhere. The main functions, I mean. Now what I want to do is I want to add a event listener to duplicate this file. I'll just call it demo4. Now I just want to add an event listener for error control frame. So whenever there is an error, this control frame would this be this callback function would trigger, and it's hard to replicate this issue. I mean, there could be any reason as to why this happens. It could be an issue from the Bybit end, but it's good to have this handled in the code. So what I would generally do is whenever there's an error, we just restart. We just wait for a few seconds and restart the bot, restart the WebSocket. So I make it async function, and again delay. I'll just add maybe 5 seconds delay, uh, and then I'll just restart the function. That's it. One thing though is, in the restart function, you can see that it tries to establish the new connection right away. But if a WebSocket is already open, then this statement would throw error. So what you would want to do is, if the WebSocket is already active, we just say WebSocket.terminate at the beginning. That's it. So in doing so, whenever a restart is called, it terminates the old connection before starting a new one. It's just safer to handle it. Okay, that's it. Now let's look at ping pong frames. So ping frame is a mechanism that is used in WebSocket terminology to ensure that the connection is active between your code and the Bybit server. So let's look at the documentation a little. So it's not mentioned here, but if you go to version 5, the documentation here is more comprehensive. I think here is just I think they didn't want to repeat everything that was said here, but yeah, if you go to version 5 and connect, this is where they documented the steps accurately. So if you scroll down, you will see the recommendation here. Where is it? Okay, so to avoid network program issues, we recommend to send a ping frame every 20 seconds. So so every 20 seconds we can send a ping frame to ensure that the connection is active. So let's see how this works. So I want to create an interval, ping interval, make it 20 seconds. Okay, and also capture the function, create a reference for the function. So ping trigger, let's call it ping trigger. Okay, so what you want to do is make it let. Okay, clear interval, ping interval. Again, just like how we terminate before initiating, we just clear interval, and ping trigger is equal to set interval, and have a callback function, and the interval period is ping interval. Again, just make sure the WebSocket is open here. So I'll just copy paste this code here, and then we just have to send a ping frame. That's it, right? WebSocket dot ping. That's it. So when we restart the WebSocket, we're just sending a ping frame every 20 seconds. That's it. Now we can listen to this by adding an event listener to Pong control frame. So it'll say Pong on Pong. The names are a bit funny, but yeah. So every time you send a ping frame, the server responds back with a Pong frame. So that's what we're trying to capture here. Constant on Pong. I'll just say WebSocket Pong received. Okay, let's restart it. Demo 5. So WebSocket is open, the connection is established. Like after 20 seconds, you should see a Pong frame. The Pong received. So every time you receive a Pong frame, that is a way of validating that the connection is active. Now, using this ping pong mechanism, we can implement a functionality called heartbeat to re-establish the connection if there is a network issue. So before we write the code for that, I want to take some time explaining how that works. All right, and now let's understand how to identify when there's a network issue and how to re-establish the connection. So let's say this is x-axis and we send the ping frame every 20 seconds, right? So let's put a marker over here. And let's say this is the Bybit server. And every 20 seconds, we send the ping frame. And if the connection is active, we get a Pong frame back. So that's similarly, again, if we, after 20 seconds, if we send a ping frame, if the connection is active, we get a Pong frame back. What we do is when we get the Pong frame back, we schedule a deletion or reconnection job or a function after 25 seconds, or the timer should be slightly longer than this window. So let's say this is 20 seconds, right? So we'll keep it 25 seconds. Okay, so what we do is when we receive the Pong frame, we delete the previous job and we create a new job 25 seconds from that point in time. So let's say let's see how this works, right? In the next frame, again, we send a ping frame, and if the connection is active, we get a Pong frame back. So what we do is we cancel this job and we create a new job again 25 seconds from this time. So it's works. So let's say for whatever reason the connection is not active here and it got disconnected. So then when we send the ping frame, we don't get the Pong frame back, right? So this job would not be cancelled. It's set to trigger and this creates a new connection. So yeah, if the connection is active, this job is deleted and we wait for the next window. And that's how we ensure that if the connection is active, this job is never triggered, right? We don't want to reconnect if it's already active. And if it's disconnected for whatever network issue, we this function is triggered and it creates a new connection. This functionality is very similar to debounce. So if you're familiar with debounce, debounce is a concept that's used in a lot of front-end applications. It's used to, prevent noise from rapidly clicking buttons or even the search field, right? So let's say you have a button that triggers some API call. Let's say if the user keeps clicking the button rapidly, right? We don't want to call the API every time. So what we do is we wait for a certain window, and only when the user doesn't click for a certain window, we then trigger the API function. So that's one way to do it. We do the same thing for even the search field, right? Generally, when we are typing, we want to call the search after we are done typing. So we use a debounce function, debounce up concept for that. So we just wait for a few milliseconds after the user is done typing, and only then we trigger the search function. But yeah, in this case, we are using heartbeat. It's called heartbeat in the context of WebSockets to keep your WebSockets resilient to network issues. Now that we understood how this works, let's implement that feature. I'm going to clone the previous version, and then I'm going to create an interval for that. I'll just say heartbeat interval. It should be slightly longer than the ping interval. So I'll just say 25 seconds, keep it 25 seconds. And then I also want to keep a reference for that function. So heartbeat trigger, that's it. So what all we have to do is in the Pong, whenever we receive the Pong frame here, we clear the previous instance of the function, heartbeat trigger, and then we set a new function. That's it. We clear the previous trigger and we create a new restart function 25 seconds into the future from that point in time. So that's how we do it. I just want to add one thing. I just want to add a console log statement here just to know that I want to know when this function is triggered. Okay. So, okay, let's run it again. But it would be hard to demonstrate when this is triggered, right? Because I have an active connection and this wouldn't happen so often. So in order to trigger this, what I want to do is I want to stop sending the ping frame after the first time. That way, this scenario will be replicated for you to see that the heartbeat function really works. So I'm going to do this in a new version. I'm going to put a flag for this, ping flag. And I only want to send the ping frame once, right? So what I'll do here is if the ping flag is true, return. Okay. But if it's not true, then say ping flag, set the value to true, and then send the ping frame once. So this would ensure that we only send the ping frame once. So the next time when this is triggered, we don't send the ping frame, so we don't get the pong frame back, and this restart function should trigger. So that's what I want to show you. So let's run it. The connection is open. The pong is received, so that should trigger the restart function. So in the next 25 seconds, we should see the connection being restarted. Perfect. So heartbeat is triggered and we created a new connection. Awesome. So this works as expected, right? But one issue that you see here is, after we reestablish the connection, the bot doesn't subscribe to the previous topics, right? Which is not what we want, right? Whenever there's a restart, whenever the bot restarts, we want the bot to reconnect to the previous topics. So let's implement that. Duplicate the file. Okay. So for that, I want to store the subscriptions in an array. And what I would want to do is every time we subscribe, every time we call the subscribe function, we want to update the subscribe function with the topics. And every time we unsubscribe, we want to update the topics to subscribe is equal to subs.filter topics.include d. So when we call unsubscribe, we just filter out those from the array. And every time we open the connection, we do the same thing. We just copy this code here and we just call the subscribe. Yeah. So every time we reestablish the connection, this on open event would trigger and we subscribe to the previous topic. So let's run it again. To keep it simple, maybe I'll just delete. We don't want this, right? We'll just add these two topics. So after the bot reconnects, it should connect back to these two topics. So let's run it. Node demo 8. Yeah. So WebSocket open. First, you should see the ping pong triggered. Okay, pong frame received. Now it should schedule the restart job. We just wait for the connection to restart. So yeah, the heartbeat got triggered. The WebSocket is a new connection is established, and you can see it did subscribe to the previous topic. So So yeah, this ensures a seamless connection, right? Even when there's a network issue, you want the code to reconnect back to the previous topic. So which is what we implemented here. I just want to delete this ping flag here because we just did it to demonstrate that, right? We don't want that to happen. So I'll just delete these two. That's it. So now you have a fully functioning WebSocket module. You can just take this code and use them in your project. All you have to do is export the restart, subscribe, and unsubscribe methods outside this module, and you can use it. And everything else, like the network issues and everything, is handled internally. Next thing that I wanted to show you is authentication. So to do that, first you need to create API keys. Uh, I've created an API key and you can see the permissions that I've given. Make sure you give access to the spot reading, and I've restricted access to read only, because I only want to show you how this works, and that's it. So here is the URL for the private topic. So I'll just copy this URL, go back to the code, just copy the demo 8. I'll call it private one.js. I'll change the URL. First thing that we need to do is load the API key. So I can just copy and paste the keys in the code, but that's not the right way to do it. So I'll create an environment variable and paste my keys here. So I've I've copied my keys over here, but I'm going to delete these keys after making this video. So yeah, I'll close all the other files. And first let's load the keys, right? First I'm going to import .env module, and in the core logic we'll say .env.config. So that loads API keys. And what we want to do is when we open the connection, we want to handle the authentication here. Okay. So for that, I'll create a function to generate the token. We want to generate a token using the secret key, and we send that token as a message to authenticate. So I'll show you how this works. So okay, generate token, call it auth token, and the inputs for those are API key and a secret key. Okay. Oh, sorry. Yeah. We need to set an expires date because we want to set an expiry date for the token. So I'll just put it 10 seconds from the current time frame. So new date dot get time plus 10 seconds. Next, I want to create the signature. To create the signature, I need to import the crypto module. This is a standard Node.js module. I don't need to install anything. So I'll just say import crypto from crypto. Okay. Crypto dot create hmac. Yeah, this one, create hmac. SHA-256, that's the algorithm. And we're going to pass the secret key here. So before we do that, I need to import my keys, right? API key and secret key from process.env. That's where we have the environment variables. Yeah, secret key. And then what message do we want to create the key for? So right, just get slash real time plus expires dot digest hex. Again, the documentation for this is available on the official Bybit website. So what we're doing is we're creating a signature for this message. This is the message, get real time plus expiration date using the secret key. That's it. Then we create the payload. Operation is equal to auth. Remember the previous operation was subscribe and unsubscribe. This is authentication, so it's called auth. And arguments, we need to send three arguments: API key, and then signature, sorry, expires. Expire should be in the form of a string, so I'll just say to fixed of 0. That converts number to string, and then we pass the signature. Scroll down. That's it. And then we have to return a stringified version of this payload. That's it. So yeah, we for to this function we pass the API key and secret key. We create an expiry date 10 seconds from now. We create the signature, and then we create the payload for authentication, and we just return it. Now we just need to call this function inside the on open event. So auth token is equal to generate signature of API and secret key. We should do this here, this thing. Yeah, I'll just cut it because we are passing it as parameters, right? So we do it here, and then we send these two, and then we say ws.send, sorry, auth token. That's it. Let's run it. I'll delete this because we're not subscribing to any public topics, so I'll delete these two. So what we're doing is we load the environment variables, then we're restarting the connection. And when we restart this, as soon as the WebSocket opens, we authenticate, uh, you know, using this auth token. I don't want to call this because I just want to add a function here. So if subs.length, not subs.length, return, because we don't want to send anything if there's no topic to subscribe to, right? And we don't want to subscribe yet. So that's it. Let's run it. Okay. You can see that authentication is successful, right? WebSocket is open and operation auth is success. That means, the authentication is successful. So now what I want to do is I want to subscribe to some topics. So if you go to version 3, private channel, there are different topics to subscribe to: order, stop order, execution, and wallet. So I'll just subscribe to the order uh, topic. So let's scroll down and subscribe uh, to just order. Okay. Let's run it again. Awesome. So authentication successful, and after that, we also subscribe to the order topic. Okay. Now let's create an order, right? Uh, yeah, I'm on the interface. I have a BTC USDT. I'll just create an order, limit order at 20,000, 0.001, whatever. I want to see the order come in. So if I say buy BTC, yeah. If we go back to the awesome. So as soon as I place the order, you see, a new order got created. We got an event for that. So it includes all the details related to the order. If I if I cancel this order, you'll see another message here. So if I cancel it, you see the order got cancelled. You would do so any order that you place, right? If the order is filled, if it's a market order, or if it's a limit order that got filled, you will see the trail of messages over here, and you can use this to, you know, take some action. Remember when we started the video, I talked about, if you have a limit order in the exchange, how do you avoid polling the server? So this is how you do it. So you just connect the WebSocket, and you don't send any messages. When the order is filled, the server itself will send you an event for you to take some action on. So yeah, that's the beauty and power of WebSockets. Finally, I want to end the video by showing how you can connect your browser to the WebSocket. Like I explained in the beginning, you cannot directly connect the browser to the WebSocket because of the CURS issue. So right now what we have is our Node.js server that is connecting to the Bybit WebSocket using the WS package. So what you would additionally have to do is implement a Socket.io WebSocket on the Node.js server that allows the browser to connect to it, and will relay the information that we get to the browser using the Socket.io connection. So yeah, just to summarize, we'll use the Node.js server as the intermediary layer to relay the information that we get from the WebSocket to the browser. One last thing that I want to say is that there are many ways of doing it, but I'm going to focus in this video on getting it done with the least amount of code and not to spend too much time on the best practices. And in order to implement this, I need Express package to create the Express server, and also Socket.io to create that Socket.io connection to the browser. All right, let's get started with the code. First, I'm going to install these two packages, Express and Socket.io. Okay. Then I'm going to move some of these files into a different folder so that it's easier to manage. So I'll create one folder called public and move all the demo files to that folder because these are all related to the public WebSocket. And then I'm going to create another folder called private and move all the private related examples to that folder. That's it. So now I'll going to create another one called browser, and this is where we'll implement the code to connect to the browser. Okay. So inside the browser, I'm going to create a file called app.js. This is going to be our main module, and I'm going to create a folder called utils, and I'm also going to create a folder called pages. Okay. So yeah. So here, okay. First, let's go to the public page, and I'm just going to take some. Let's just take demo 5, right? I think it has all the features. Yeah. Let's just copy demo 5 and create a utils. So I'm going to create this module. You know what? Let's delete this. I'm going to use demo 8 because it's the completed one, right? That is what has, that is where we built, the final version of the WebSocket. So I'm just going to copy that and paste it here. I'm going to call it Bybit Websocket. Yeah, it has all the ingredients, right? It has all the components that we wanted to build. So yeah, then I'm going to create another file called helper. Sorry, helper.js. Yeah. Let me rename this. Okay. So I want to delete a few things over here. So we want to use this as a module, right? So we don't want the core logic over here. So I'll just delete this. And I want to export some functions from here. So I want to export the restart function. So let me just create a variable called Bybit Websocket. And I'll list all the functions that I want to export. So I want to export restart, subscribe, and unsubscribe. Sorry, unsubscribe. Yeah. And I'm also going to create a event emitter because every time I receive a message, I want to emit that message, so that I can catch it in the app module and then send it to the socket IO. So let's do that. It's quite easy. So I'm going to import events from events and let event emitter is equal to new events. That's it. So I'm going to export this event emitter too. So over here, just going to export this. All right. Another thing, I'm using delay function in multiple places, right? Uh, because we remove the core logic from here and we're going to implement it over here, I'm going to need the delay function outside this module. So let's create a generic delay function over here and we'll use it wherever we want. Okay. So let's do it. Let's copy this line. Yeah. And then this thing. Yeah. Okay. So I'm just going to say export constant. That's it. So now, I can use delay wherever I want. So I just have to import it over here, import delay. That's it. Perfect. So there's that. What else? Yeah, I just have to say export default Bybit WebSocket. Okay. Now let's go to the app module and let's import. I think here we also don't need the .env. Yeah, we're not using .env anyway, so it's a public WebSocket. So yeah, let's create an immediately invoked function expression async. Sorry. Okay, we're going to implement all the core logic over here. Okay, so I'm going to import Bybit WebSocket first. Okay, I have to include the .js extension and we're just going to follow the same thing, right? I'm also going to import the delay function. Perfect. So first is, I'm going to restart the WebSocket and then await 1 second, just for the WebSocket to change the status to open. And then I'm going to subscribe to, what is it? Subscribe to this topic. So I'll just copy the topic from here. What was that? Yeah, K line 30 minutes. We'll just select one topic for now because this is just for demonstration purpose. So let's go to browser and let's start app.js. Let's see if it's running or not. Perfect. So the WebSocket is open and the subscription is successful and we are able to see the data come in. Okay. Perfect. So now let's create an Express server and then the socket IO server using that Express server. So let's do that. import express from express. Okay, then express listen to port 5000 and console.log. Okay, so we just created an express server. Now let's create a socket IO connection. I don't have to comment this. uh, for that, let's import the socket server from here. Import server, yeah, server from socket IO, and then constant IO is equal to new server of, we pass the express server as a parameter. Okay, we'll just leave it at that. So let's start it again. Let's see if it works. Let's go to the browser, node app.js. So yeah, it is working, and you're also able to see the express server getting started on port 5000. Now I just want to create a basic HTML page, just a generic HTML page, index.html, and I'm just going to call it my page. It doesn't really matter. Like I said, the focus is to get it done with the least amount of code. So I just want to show you how it's done. But yeah, this is not the best practice. I mean, I'm only showing it because it's relatively easy to do. And if you have to create a quick and dirty script, then this is the way to do it. Okay. So first I need to import that socket.io client CDN, right? So I'll just copy this. This is the URL for that socket.io CDN. So I'll just import it here. Yep. And then I'm also going to create another script tag. Okay. So here is where we'll write the code for the socket.io connection. Let me quickly summarize what I just did, right? So in the server, we have created an Express server and a socket.io layer on top of it. And we're also starting the Bybit WebSocket and subscribing to this topic. Okay. We are receiving the data, but we're not still sending it to the browser. For now, I'm just creating this index.html file. And I just want to establish a connection to the Node.js server. So we do that by saying constant socket is equal to io.connect. This is a URL for it, right? It started on port 5000, right? So the URL would be http colon 127 dot colon 5000. That would be the URL. And on connect connection, we just want to log a console message that connection successful. Okay. So let's open this in the browser. You can either hit go live and open it in the browser, or you can manually go to the folder and open this file in your favorite browser, Chrome, Safari, whatever. Okay. So I'm just going to start from here because it's easier for me to do it this way. Awesome. So it's open, but you can see that the connection is refused. I think it's happening because of the CORS issue. So let me uh, go to the app. Sorry, we're not running the app, right? So let me go to the browser folder and start the server. Okay, now if I restart the page, you can see that it doesn't allow the connection because of access control allow origins, because of the CORS policy. So the reason this is happening is because when you started a live server on your index.html file, it starts on 5500 port, whereas your app is running on 5000 port. So these two are of different origin, right? Which is what makes the browser to block the request by default. So you can fix that issue by specifying the CORS configuration over here. So all we have to do is pass the CORS configuration. CORS, we just pass an extra options to the IO socket IO server, and we say origin star, as in just allow origin from anywhere. Again, this is not the best practice. This is not how you would do it. But like I said, just get it done easily. The focus is, just get it done with the least amount of code. So I'll restart the server, uh, and let's go back to the web page and refresh the page. uh, I guess it wouldn't take a callback function, so let's do this. And yeah, perfect. So now, awesome. So now you can see, after we added the CORS policy, the connection is successful. Now what we need to do is we need to relay this information from the Node.js server to the browser. So we have created this event emitter, right? So all we have to do is, in the message control frame, whenever we receive a message, we just emit a we just emit the data on a particular topic. So let's just say WS data. I'm just creating this random topic. It could be anything. And then I'm just going to send the same data over here. Okay, just paste it. All right. Now go to the app file, and here we just add an event listener to that, and we can just say bybit websocket dot event emitter dot on. So whenever we receive a message on this topic, all we do is make sure the topic name remains the same, right? WS data. And here also we just say WS data. We just send the data to all the connections. So we just say io.emit payload. That's it. Okay. And even in your index.html file, we should add an event listener to on this topic. Okay, WS data, and I'll just say console.log. Okay, so whenever we receive a message on this topic, we just log the data to the console. All right, let's restart the server and go back to the browser, refresh the page. So here, when we emit the data, we need to specify the topic as well. So just specify the topic here and emit the data. Let's restart the server. So we are sending the data to the client, to the browser on this topic, right? Because here we are listening to this WS data topic. So we have to send the data on the same topic as well. So we did this and restarted the server. Let's restart again. Awesome. If we go back to the browser, awesome. You can see the data coming in, right? Refresh the page. You will see the data, because we are just logging the data to the console. You can see the data come in. So yeah, that's a quick and dirty way to, just send your WebSocket data to the browser. So using Node.js as your intermediary server. Although we have used Bybit WebSocket to demonstrate the functionality, the focus of this video is primarily on WebSockets and the concepts involved, in creating and maintaining a WebSocket, and the emphasis is less on, the concepts that are related to the Bybit exchange, right? So the core concepts that we discussed, right? The control frames or heartbeat, or or actions that we take. So those concepts are similar across all the exchanges that you work with. So the concepts that we discussed in this video are applicable for for most of the WebSockets that you work with. There will be a few differences, in how you handle the ping frame, or how you ensure the connection, how you restore the connection during network issues. So it differs slightly, but for the most part, the concepts that we discussed are applicable for most of the WebSockets. But yeah, I mean, this is not yeah, the focus is less on Bybit and more on the WebSocket functionality. But if you want me to make a detailed video on Bybit WebSockets, we can talk in depth about what are the different topics and how the data is structured within these topics, and how to like extract the information that we want, and all that. So that would require a video of its own, that deserves a video of its own. So let me know if you want me to make that video. I'll try to cover that as well. That's it for this video. I hope you have a great day, and we'll catch up in the next one. Bye.